Hello everyone, myself Shinde V.G., working as Assistant Professor at Department of Nanoscience and Nanotechnology, KTM College, Nasik. Today we have going to discuss T.Y.B.Sc Semester 3rd, paper number 2nd, that is the course of Nanophysics. In today's lecture, I have discussed the random walk problem. The random walk problem is of considerable interest in statistical physics. We shall discuss this problem in this section as an application of binomial distribution. Means the random walk problem is the application of binomial distribution. The original problem solved by Markov can be formulated in the following way. First one, the random walk problem is solved by Markov. Okay, it is the following way. A drunkard starts from a certain lamp post on a street. Some of steps he takes are forward and some backward. Each step is of the some length and is completely independent of the preceding step. Means one person of drunkard, this is the certain length to travel. This length is lamp post on a street. Some steps, this distance are traveled by, some step is forward and some step is backward. Each step is of some length but is completely independent, that is of the preceding step. This problem solved by the formulated or solved by the way of formulation by the first one by Markov, discovered by Markov. What is the probability that the drunkard, after taking n steps, will reach his destination, which is at a distance x from the lamppost? This problem by the calculating probability of a drunk person after taking capital N steps and the distance travel x by the lamppost. Consider a particle undergoing successive displacements, each of length L in one dimensional. Means the one of consider a particle undergoes successive displacement, each of length L in one dimensional. What is the probability that the particle after n such displacements, capital N such a displacement, will be at a distance x is equal to ml, where m is an integer. Let n1 be the number of displacement to the right and n2 to the left. Means these particles we have traveled or displacement by the right hand side is n1 and left hand side is n2. Therefore, capital N is equal to n1 plus n2. n1 means right hand side displacement and n2 means left side displacement. That is the equation number first. The net displacement to the right is, it is the equation of ml is equal to, ml means x, ml is equal to in bracket n1 minus n2 bracket into n is equal to n1 minus in bracket n minus n1 bracket complete, another bracket complete into l. Here n minus capital N minus small n1. Is the n2 value from equation 1, the n2 value put up in this equation. In ml is equal to in bracket n1 minus n2 into l is equal to in bracket n1 minus another one bracket capital N minus small n1 bracket complete double bracket complete into l. That is equal to, this equation is simplified that the in bracket 2n1 minus capital N bracket complete into L. That is the equation number second. If the probability that the displacement is to the right is P and the and that is to the left is Q. Q is equal to 1 minus P. The total probability is equal to always 1. That's why the left hand side is Q probability, that is equal to the 1 minus right hand side probability. Okay. Now, then the probability of a sequence of n1 steps to the right and n2 steps to the left is, that is equal to p raised to n1 q raised to n2, that is the equation number 3rd. Means the probability of right hand side and left hand side. Right hand side probability is p raised to n1 and left hand side probability is q raised to n2. However, there are various ways in which a particle may undergoes n1 displacement to the right and n2 to the left. However, there are various ways in which a particle may undergoes n1 displacement to the right and n2 to the left. Means this equation is simplified that the n1 is displacement to the right and n2 to the displacement to the left hand side. That is proved that. For example, suppose a particle undergoes 3 displacements, means one particle that have 3 displacements, 2 of which are to right and 1 is left. These may happen in 3 different ways as shown in figure. Let's have figure showing that 2 is right hand side and 1 is left hand side. In showing figure, 3 steps by. First step is also 2 steps are right and 1 is left. 2 steps are right and 1 is left. 2 steps are right and 1 is left. This figure showing that the 3 different ways of a particle. Now, the number of distinct possibilities in the problem we are consider is equal to capital N factorial upon small n1 factorial into small n2 factorial, that is the equation is considered as 4 number. Therefore, the probability of n1 displacement to the right and n2 to the left in any order is. The any order that is equal to capital N factorial upon small n1 factorial into small n2 factorial into p raised to n1 q raised to n2, that is the equation number 5. In here, the number of distinct possibilities, that is the equation is considered that this one, and the probabilities of n1 is right hand side and n2 to the left hand side. This probability is written here. The p raised to n1 is the right hand side probability and q raised to n2 is the left hand side probabilities. Since the problem of a displacement in either direction is 1 by 2, that is the p is equal to q is equal to 1 by 2. From equation first and second, the n1 is equal to n plus small m upon 2 and small n2 is equal to capital N minus small m upon 2. That is the equation number 6. Therefore, the probabilities that the particles will be at x is equal to ml after the n displacement is given by. After the n displacement is given by Pn m is equal to c into capital N factorial upon in bracket n1 value put up here. n1 value put up here. The n1 is capital N plus small m upon 2 bracket complete factorial. In another one bracket, the n2 value put up here, capital N minus m upon 2 bracket complete factorial into 1 by 2 raised to n. That is the equation number 7. 1 by 2 means p is equal to q is equal to 1 by 2 raised to n. N number of displacement. Okay, n steps displacements. That's this is the equation number 7, where c is the normalizing constant. Taking logarithm by this equation, The taking logarithm ln Pm is equal to ln C plus ln n factor capital N factorial minus capital N ln 2 minus ln in bracket capital N plus m upon 2 bracket complete factorial minus ln in bracket n minus small m upon 2 bracket complete factorial. That is the equation number 8. Using the Stirling formula is ln n factorial is equal to n ln n minus n plus 1 by 2 ln in bracket 2 pi n bracket complete. That is the equation number 9. This is the Stirling formula. That use that the equation number 8, the ln Pn m is equal to ln C. C is the normalizing constant plus capital N ln capital N minus capital N plus 1 by 2 ln 2 pi plus 1 by 2 ln capital N minus capital N ln 2 minus in bracket 1 by 2 in bracket 1 plus small m upon capital N bracket complete, another one bracket complete into ln in bracket capital N minus 2 in bracket 1 plus small m upon capital N bracket complete, another one bracket complete plus in bracket capital N upon 2 in bracket 1 plus small m upon n bracket complete, another one bracket complete minus 1 by 2 ln in bracket 2 pi bracket complete minus 1 by 2 ln in bracket capital N upon 2 in bracket 1 minus small m upon capital N bracket complete, another one bracket complete minus in bracket capital N upon 2 in bracket 1 minus small m upon n bracket complete, another one bracket complete ln in bracket capital N upon 2 in bracket 1 minus small m upon capital N, another one bracket complete plus in bracket capital N upon 2 in bracket 1 minus small m upon n bracket complete, another one bracket complete minus 1 by 2 ln in bracket 2 pi bracket complete minus 1 by 2 ln in bracket capital N upon 2 in bracket 1 minus small m upon n bracket complete, another one bracket complete. That is the equation number 10. This equation 8 is using by the Stirling formula. That's why the simplify that the equation number 9, that equation 9 by using that the equation 8. 8 equation is simplified, that this is the simplification by the 10th equation. Okay. If small m is very less than capital N, which is generally true, that's why the equation is ln in bracket 1 plus minus small m upon n bracket complete, that is equal to plus minus small m upon capital N minus small n square upon 2 capital N square plus minus, that is the polynomial. That's why the substituting in equation 10 and simplifying this value, this equation or this value is substituting that equation number 10 and simplifying that. The simplifying that ln Pn m is equal to ln in bracket 4c square upon 2 pi n bracket complete raised to 1 by 2 minus m square upon 2n. That is the simplification equation of 10th equation. Simplifying equation of 10th equation. That's why therefore the Pn that is equal to C in bracket 2 upon pi n bracket complete raised to 1 by 2 into e raised to minus m square upon twice n. Now the integration over minus infinity to plus infinity Pm dm is equal to 1. Therefore the C Pn value that is put up here and constant term here in this equation Pnn is equal to, in this term written here, the constant term is written by integration over. The integration, that's first one, the written constant term c in bracket 2 upon pi n bracket complete raised to 1 by 2 integration over minus infinity to plus infinity e raised to minus m square upon twice n dm is equal to c in bracket 2 upon pi n raised to 1 by 2 into 2 under root 2 pi n into under root pi upon 2. That's why this equation is simplified, that is equal to 2c is equal to 1. That's how c is equal to 1 by 2. Therefore, the Pnm is equal to, in bracket, 1 by 2 pi n raised to 1 by 2 into e raised to minus m square upon 2n. That is the equation number 11. This is the probability function for m axis displacement to the right. We can find the expression for the probability in terms of distance x and the time t by substituting equation 11. X is equal to ml and n, capital N is equal to nt. This is the value put up in equation number 11. That's why substituting this equation 11 can be simplified. Therefore, the equation is px dx is equal to, in bracket, 1 by 2 pi l square nt bracket complete raised to 1 by 2 e raised to minus x square upon 2 l square nt dx. That is, this is the normal or Gaussian distribution. In this lecture, I have discussed the random walk problem. That's why, for example here, and the express or simplify that the problem of random walk and the normal form of Gaussian distribution also studied. Thank you.